Okay, so these are the objectives that we're going to be looking at. So we're going to be drawing dot and cross diagrams, right, for covalent as well as ionic bonding. Remember when we said dot and cross, it's self-explanatory. What did we say about dot and cross?
So you're giving away elections as well?
No, we don't reach to that point as yet. Like the dot and cross, right? Remember, we have a dot and a cross. So those are what we're going to be using to represent electrons, right? So you have a dot, which will represent it something looking like a full stop, right? Something like this. And then we have what we'll deem as a cross, right? Those are what we'll use to represent electrons on each element that is participating in the bonding. Tell me if you're not understanding a part, so I can walk. You have that and cross.
So
Go again?
Explain.
I didn't hear.
Sorry, I understand what you say.
Oh, alright. So you have that, right? Which basically means like you just have a full stop, if you want to remember it easy. And then you have a cross. Good. So these are what you're gonna use to represent bonding taking place, the type of bonding taking place. And we said the bonding is what? What are the types of bonding we have?
Covalent, ionic, and metallic.
So we have covalent, that's one. And then we have ionic. Remember, we also have metallic. Good. So remember in this, right? You remember what did we say about covalent again? What's taking place? What's happening in covalent? What's the keyword we're looking at for covalent?
Sir?
What's taking place in covalent? So these are bonding. These are the types of bond. We have covalent, ionic, metallic. What's taking place in covalent again? What's happening to it? Go again.
They're sharing electrons.
Good. So they're sharing what we deem as electrons. So sharing. So I'm just gonna write sharing because so they're sharing. Let's write electrons. They're sharing electrons. Good. And what's taking place in ionic again?
So they are giving away electrons.
What exactly is who is giving away who?
Sir?
Who is giving away the electrons? Is the metal or non-metal?
Metal.
Good. So the metal right, so I'm just gonna use a diagram to represent that. So metals, they're gonna transfer electrons, right? So this would say, for example, this would be an electron. It's gonna transfer the electron to what? What is gonna transfer the electron to?
Non-metals.
Good, non-metals. So in essence, non-metals, right? They're gonna receive the electron, an electron from a metal. Could be, doesn't necessarily have to be, and it could be 1, 2, depending on the amount that they need to bond. We did this already. So non-metal. Good. And then in metallic now is just, for example, right? It's just a metal surrounded by a sea of electrons. So for example, you have sodium, right, surrounded by a sea of electrons. So that's what we mean by metallic bonding. So you have a metal, right, surrounded by, so a simple diagram to represent that. You have a metal surrounded by a sea of electrons. So metal surrounded by a sea of electron. Right, that's a simple diagram to represent it. So that's a quick recap as it relates to the type of bonds. These are the type of bonds, right? What else? So let's go to our next page. Add page. We're going to page 2. So we're gonna go in now to dot and cross diagrams as it relates to, let's say, a simple ionic bonding, right? Remember what we did on page 1, right? We mentioned that you have metals transferring electrons to a non-metal. So do you have any idea of a metal? Give me an example of a metal.
Sodium.
Good. So we have sodium. What's the symbol for sodium again?
Na.
Good. So we have Na. So that's sodium. So we're gonna show the dot and cross diagram for sodium and chloride. So it's got the simple one is gonna form sodium chloride. That's the regular salt that you use at home. That's the table salt that you have at home, that mommy and daddy use to season up the chicken and so on. Unless they're idle, they're rust, they don't need any seasoning. Alright, so let's go. So we're saying it's Na. Remember, when you're doing the dot and cross diagrams, what you need to do, you only need to show what's taking place on the last shell. And we say the last shell is known, what's the name of the last shell? The last shell is known as the
Outer shell.
Yes. Same thing. So it's either the valence, shell, that's the name of the last shell, or the outer. Valence is the same thing as outer, right?
Yes, sir.
It's the outermost. So in case for sodium, right? So sodium have how many on the outer shell?
1.
One. So we're gonna use a dot to represent that. Sorry, not a dot. We're gonna use a cross. You can use either one, but we're gonna use a cross, which is that. Because I mentioned on the first page that we have, where is it? On the first page. It's right here. So we have a dot and cross, right? Remember, so this would be the cross. So again, simple illustration for those who are following. So you have a dot, which would be this. Make sure let it draw properly. So you have this, which would be the dot, and the other one would be the cross. So we're gonna use a cross. How do we know that how do we know that it so how do we know that it have how do we know that there is one electron on the outer shell of sodium? How do we how do we know that there is an electron? There is only one electron on the outer shell of sodium. What do we use to determine that? Remember?
No, sir.
I remember we used I'm gonna do another video on this, put it on YouTube, but not hopefully in the coming days. So remember we normally use the EC. Which EC means electronic configuration. Configuration means basically how the electrons are arranged on the shell that you have on sodium. So remember, so it's to remember the atomic number, right? Remember the atomic number, so it's 11. Sodium atomic number is 11, right? You can double check the periodic table, right? If you're having doubts. So it's 2, 10, and 11. That's what we mean by EC. EC basically means how the electrons are arranged on the shell, right? Following?
Yes, sir.
Good. And then chlorine. How many electrons we say chlorine have on the outer shell again?
It's CM1.
No. You have a periodic table?
Yes. Let's see.
Double check it. Remember when an easy way to get it done, remember you look on the group number. You look on the group number where you have the particular element participating in bonding. So which group do we find chlorine in again?
Oh, sorry, 7.
Good. They're in a group 7, so that therefore mean it has 7 on the outer shell. And the atomic number is what again?
Sir?
What's the atomic number again for chlorine?
On the outer shell.
Now give me the total atomic number. Remember the atomic number?
17.
Good. So it's 2, 8, and 7. So 8 and 2, 10. And the one here says 7. That therefore means it has 7 on the outer shell. So when you draw that and craft diagram, we only need to represent those on the outer shell. Now, what I normally recommend for you to start out single first. So you normally just start out single and you start to pair. So I'll start out single. So you start simple, then when you have sufficient knowledge, you can start by doubling. So remember it has 7 on the outer shell. 1, 2, 3. I start to pair now. Start to pair, and we have 7 now. We can double check it to confirm. So we have 2, 4, 6. Let's see, 7, right? Remember, as it relates to the shell being filled, how many does it need to have on the shell to have a full shell?
Sir?
How many does it need on the shell to have a full shell? How many in total?
2.
No man, no, alright, not in this. Alright, how many chlorine need to have a full outer shell? In this case, you understand the question I'm asking?
How much,
Alright, how
Sir?
many yeah, alright, you see, you can touch. Alright, yeah, alright, how many chlorine need on this outer shell now? How many does it need to have a full outer shell? It has 7. How many more does it need to have a full outer shell?
1.
You need 1, right? Remember the full outer shell, when it's supposed to have 8 to have a full outer shell when it comes down to the third shell, right? At this level, right? You need 8, right? I'm gonna do a next video on that as well. So 2, 4, 6, right? It needs 1. So that therefore mean it's not Christmas as yet, but therefore the sodium is gonna give away the 1. The reason why sodium need to give away the 1 is because it wants to have a full outer shell, right? So look at it. If it's supposed to give away this, when it gives away the 1, it's gonna have how many on the other shell now, the second shell.
Sir, repeat again.
When it gives away this 1, right? How many is gonna have on the shell? How many gonna have remaining right there?
Sir, that's the 2, 8 and 1.
Yes, right. So that therefore mean the second shell hold a maximum of 8, right? So it's gonna have sodium after sodium give away this 1 to chlorine in a few minutes. I'm gonna draw that, right? It's gonna have 8. It's gonna make it have a full outer shell now. So drawing the dot and cross diagram, right, to represent the transfer of electrons. So this electron is gonna move from sodium, right, to chlorine. Good. Then you're gonna have this forming. After the bond, they're gonna form what we deem as ions. Supposed to have an understanding about that. So ion is when the atom become charged, right?
Yes, sir.
So it's either is a cation or anion. So they now become ions. That's when they're gonna become charged, right? And what's the charge they can possibly have? What's the charge they can possibly have again?
Sir?
What's the charge? What's the two charge they can have possibly? Give me the charge.
Positive.
Good. So they can either become negative or positive. Positively charged. So in this case, sodium, after sodium give away the 1 electron, is gonna become positively charged, right? So those, because we looked at that, we're gonna look at that. For those who don't understand what I'm doing, we're gonna look at that in the next videos and so on. So in this case, right, it become positively charged, right? Plus is the same thing as what again? Plus what? Plus is the same thing as plus what? How many? What did we say? The amount of electron it loses, right? You're gonna write it and say, all right, if sodium loses 1 electron, right, the plus would represents it lose 1, so it can be plus or plus 1. Right?
Yes, sir.
Understand that?
Yes.
Yeah, man. So, and what we can do now, we write back the EC, so it's 28. Right, because remember say sodium give away that 1 day. So for example, it's gonna have this now 28 remaining. Then you're gonna have the chlorine atom beside it. What's gonna be the charge on chlorine?
Sir, 1.
You're missing out something. Not only the dead one. It is a non-metal, so that therefore mean what's gonna be the charge on it.
Or it charge that for sir you attack.
Yeah, what will be the charge on it? You remember what will be the charge on it?
Yet.
No. It gains how many electrons it gain?
Sir, 1.
1. And if it gains, remember the charge on it is gonna be minus. So in this case, it would be minus 1. Right? It gain 1 electron. So that therefore mean the gain that it gains 1 gonna be added to the 7. Right? To make it as simple as possible. So you're gonna have 2, 8, and 8. So now chlorine have a full outer shell. So you see it now? Let's count it. 2, 4, 6, 8. You have a full outer shell. So this would be the simple how we draw the dot and cross diagram for sodium chloride. Sodium chloride is the table salt that you use at home. So alright, tell me the part that you understand and the part that you don't get. You understand everything?
So me understand when is it the X
Mm-hmm.
that can cross represent each chemical
Use the term election.
electrons.
Why you don't get? Just mark it, put it on, just touch it on the board.
So me
Don't
understand that part here.
hear so?
Yes.
Alright. So here, well, alright, so what you do on the right side, you just basically showing, you normally put them in bracket in terms of the amount. Put the ion in bracket, right? And then the amount, the charge on the ion. The charge would basically, in terms of the amount, in terms of the number you put, it deemed on the amount it loses in this case. Because remember, this would be metal, this would be a non-metal. So sodium, remember the sodium, the atomic number for sodium is 11. So it's 2, 8, and 1. 8, 9, 10, 11. That is sodium. When it comes on to chlorine now, the atomic number 17. So it's 2, 8, and 7. Now, as I said before, you're supposed to have it. The first shell can hold a maximum of 2. Second shell, 8. Right? The third shell, 8 at the euro level. That's what you look at, 8. When you move on to higher level now, you refer to 18 and so on. But we're not going to touch on that. So 8, 9, 10, 11, that is sodium. So sodium, the reason why sodium need to lose one electron in it is that it need a outer shell, it need a full outer shell, so that therefore means it will lose the one electron. Yeah. So you lose the one electron, give it away to chlorine. 2, 4, 6, 7. Chlorine need one more to become 8 to have a full outer shell. When sodium give away this one, that will lose one. Now the charge on it would be plus, which would be the same thing as +1. So you can write plus 1. As it relates to chlorine now, right? You write it back showing the amount of electron it gains. It gain 1. So the charge on it is equal. The charge what you see on the ion is equivalent to the amount it lose or gain. So you gain 1, so that therefore mean the charge upon it a plus. No, this one lose 1, right? The charge on it a plus, right? And this one gain 1, the charge on it is -1. That's how you normally write it. So it's 2, 8, and 8, which make it 18. I'm not sure you following what I'm saying.
Yes, sir.
Sorry, yeah, so you understand what I'm saying.
Yes, sir.
All right, good. All right, so gonna let it try one and see. Let's do probably have to. I'm not sure if you're able to write on the board as quickly as possible because we have around what 5 minutes
So we
on the
can
clock.
read the book.
Yeah,
Then
man, you can do that and then you can just send me and let me check it. Or if you can do it quickly, right, and let me look at it. All right, so you're gonna do any. Try this one. Any F. So that's sodium fluoride. So try that. Try this one in the book. So for those who are watching this video, you can also try it, right, and write it in the comments as well. So just write the answer, write the well, or send us the correct answer on the media. Sodium fluoride, the dot and cross diagram for sodium fluoride. Remember, we also have like study guides for those who want the free study guides. They can reach out to us, right? The link is in the description, right? And it's also pinned in the comment section, so you can check it out as well. So free study guides, we have CSEC past papers with answers, right? And we also, if you want to book a tutor, right, you can reach out to us through Google Forms as well as WhatsApp. So you can check out all of these things, right, in the description as well.